Here's video 2 on I built an app regarding the blackjack card counting algorithm. Um, you can actually find it in the iTunes store if you're interested. So we initially on video 1 we talked about the blackjack terminal game that we found online, and it was at this website askpython.com. It's basically a very simplistic blackjack game that you can play in the terminal. It prints out cards kind of in a neat way, very simple to use. We use that as a way to test our algorithm on. And on video 1, we cover kind of how that goes through. So most of these cells we already covered. So this first cell here is just which libraries you'll need to import. The second one is dealing with building the class of card, which is used in the game. The third one is how to clear the terminal. Then you build your deck, and here's where you actually get to the card counting algorithm. So it does have some inputs. It's going to be player cards, dealer cards, deck, player score, and dealer score. P cards is a copy, essentially, of player cards. D cards is a copy of dealer cards. Deck cards is a copy of deck cards. Open cards represents which cards are actually open on the table at any given time. And cards of value left is, for example, if you had a score of 20, your goal is to get to 21. It tries to figure out how many cards are left in the deck that could get you closer to that score of 21. If you have a score of 20, there's only one card that can do that. It's an ace, and there are 4 suits of aces. So that the cards of value left in that case would be 4. If there happened to be another ace on the table, you would drop that by 1. It would only be 3 left in the deck. These 4 loops represent building the new copies of player cards, dealer cards, and deck cards. But in this case, we're only taking the card value from each card. We don't care about the suits. As far as I'm aware, when you count cards, you're only worried about the value of the cards. Then we have to calculate the open cards by just adding the player cards and dealer cards together. And we also have to figure out how many points do we have to get to 21. So we 21 minus the sum of our cards. Once we have that, we try to figure out how many cards are left in the deck that represent that value or less. So we're checking to see if that card in the deck is less than or equal to whatever value we have to get to 21. If it is, then we add or we increment the cards of value left by 1. Finally, we have to do, before we calculate the probability, we have to figure out how many cards are left in the deck once we do all this. And that's as simple as taking the 52 cards, subtracting the total cards that are out. And then in the probability, all you're doing is figuring out how many cards of the value that you have left to get to 21 are in the deck, and you're dividing that by the total number of cards that are left in the deck. A very simple idea, just saying, do I have what is my percent likelihood that I will draw a card that will be of that value or not? With this, you figure out if the probability of getting that card is greater than 50%. If it is, you hit, and if it's not, you stand. Finally, you're going to return the probability, and you're going to return the choice. And choice is actually going to be used in this next line. This next cell here, we take the original blackjack game, referenced at that URL at the very first cell, and we create a loop around it. So we're basically creating a simulated game. In this case, I only did 100 loops. My computer's not fast enough. 1,000 takes forever, and 10,000 takes a very long time. When I first ran this about a year ago, I did do 10,000. I wanted to say it took about all day. But it wound up giving me about a 52% likelihood of winning, which, if judging by my math, or excuse me, by my Google skills, that trumps a professional card counter by just a hair. So it does all right. The catch with that, of course, is in our game, it is 1 dealer and 1 player and 1 deck of cards. And in reality, usually there are multiple players and multiple decks of cards. So here we are going to calculate the wins, the losses, and we will have an index to run the loop on, and that will increment at the end of each loop. With this, all we did was take the original blackjack game and put it inside of this loop, and we're just running it till the index hits the number of loops that we designate. We still build the deck, we still do the cards, we still create the scores. Really nothing has changed until we hit managing player moves. The first thing we're checking is if the player score is less than 21. If it's equal to 21, they've hit blackjack, so you don't really need to do anything. But if it is less than 21, you will run that card counter. You're going to input the player cards, the dealer cards, the deck, the player score, the dealer score, and you're going to output the probability and the choice. That choice is then going to be used right here. If the choice is to hit, you will proceed in the game just as if you input hit. If you keep coming down, if the choice is S, then you will continue just as you did before. At the very end of that, you're going to run this again, and you'll continue with that throughout the game. And then the dealer, of course, will go about their way until they hit 21 or above. At the very end here, we have to calculate the scores. So if the dealer busts, goes over 21, your wins total is incremented by 1. If there's a tie game, nothing happens. I don't know what happens actually in a casino. It might go to the house, but in our case, nothing happens. The players, if we win, which means the player score is greater than the dealer score, and we have not hit over 21, we will increment the wins by 1. And then finally, if the dealer score is greater than the player score and the dealer score has not exceeded 21, you will increment the losses by 1. And then finally, at the very end, your index goes up by 1. So then you repeat the loop and proceed. At the very end, we're going to print the number of wins, the number of losses, and we run the code right here. I just ran 100 rounds. Like I said, 1,000 just took too long, and I wasn't willing to wait. So in my 100 rounds, I got 46 wins. I got 39 losses. I think that's a pretty good idea of how this performs. But again, the more rounds you do, the more realistic it becomes. The big idea here is that basically you can create a pretty simplistic card counting algorithm just basically by, let's go up here, figuring out what the probability is of drawing a card that would be what you need to get close to that 21 mark. And once that value is beneath 50%, you leave it as is. And then additionally, definitely make sure that you run hundreds, if not thousands, of games just to ensure that it actually works. Anyway, this was video 2. In the last video, I'm actually going to talk about how I went about taking this idea, which we got to work. We got it working well enough, and actually turned it into a user-friendly download that you can get in the Apple Store. Anyway, I hope that was of interest, and I'll see you in the next video.